Alright, today we're going to learn how to describe the position of an object using the x and the y plane, sometimes called the Cartesian plane. Uh, First of all, you'll be given the coordinates of whatever you are asked to, find the position in this form. Let's say 1, 2. Now, the first thing you must note is that the first value there is for the x-axis rather, while the second one will be for the y-axis. So generally, it's always given in the form s, y. Right? So the first value is always for the x, while the second value is for the y. So when we are given the values 1 and 2, what do we mean? We simply mean that from the origin. Now, when we are using the Cartesian plane to try to trace the position of an object, we always start from the origin, which is this point. Alright, that's the point where both the values of x and the values of y is equal to 0. So we're saying that from the origin, remember the first value given is for the x-axis. So if it's 1, it simply means from the origin, move 1 unit towards the right, because you see that value there is positive 1. So you're going to move towards the right because that's the positive x. If you move upwards, that's positive y. If you move towards the left, that's negative x. If you move downwards, that's negative y. So we're going towards the right 1 unit. So we're going to go in this direction, towards the right, and then 2 units up, because you see the value of y there is what? 2. So basically, if we represent this what is going to be like. So our y value there is 2, and then our x value there is 1. So the point where these two coordinates intersect is the position of whichever object or body we are looking for. So right there, so that will be the position of the object we're looking for. So the object will be there. That's what it simply means. So anytime you're giving coordinates of an object, what it simply means is that what value or how many units are we going towards the right or left? That would be for the x-axis, because when we talk about the x-axis, is the horizontal plane. So we're either going right or left, and then what unit are we going to go up or down to locate that object? In this case, 1, 2, meaning 1 unit to the right, 2 units upwards, and then I'm going to locate that object. So let's call the object A, for instance. So if A was what we're looking for, that would be the coordinates to locate it. All right, so what if I had another point, say 4, 6, for instance? What does this one mean? Again, remember that the value of the x-axis is given first, while this is the value of the y-axis. Now, since we have two values given for each of the coordinates, let's just call this s subscript 1, y subscript 1, right? That means our first value of x and first value of y, and then second value of x, second value of y. So in this case, 4, 6, what does it mean? All right, what this simply means is that we are going to move from our point of origin. We are going to move 4 units towards the x-axis, positive x now, because that's positive, and then 6 units towards the positive y-axis. So if I do that from 6, I like to trace mine from the y-axis, but regardless, we're still going to get something. So that's what it means. So from the x, you're going to go 4, from the origin rather, you're going to go 4 units, towards the x-axis, and you're going to go 6 units toward the y-axis, and then that's what we have. So that point where they intersect is the position of the object you're looking for. All right, so it's just a similar concept to that of bearing. In bearing, we are going to be taking the positions of the objects relative to the cardinal points. Is it towards the north, towards the northeast? So it's just similar concept, but in this case now we're using the Cartesian plane. All right, the Cartesian plane is just the name we call it because we got the name from the scientist or mathematician that introduced this concept. So his name is not really Cartesian, but I think I've forgotten his name actually, but there is Kata in his name. So sorry if I didn't get the pronunciation anyway, but that's why we call it the Cartesian plane. All right, just like Isaac Newton, if we have, for instance, we have some fluids that follow after the definitions like Isaac Newton specified, we call them Newtonian fluids. So that's why also this is called Cartesian. I wanted to call it fluid now, Cartesian plane. So this is how to represent the position of an object. So let's call that position B. So basically, it's not very difficult. So this is just how to represent position using a Cartesian plane. Now, another thing I want us to discuss is how can we find the distance between 2 points, on the plane. So for instance, you see we have these 2 points now, A and B. What if we're asked to find what is the distance from A to B? What's the distance from A to B? So let's just call the distance from A to B D. So I want to find what's the distance. How can we do that? Well, we're going to use the values of what we know to, get the answer. So first of all, I would like for us to trace out some points. First of all, let's just join these lines together to form somewhat like a triangle there. So I'm just going to join the two values of x together, and then the values of y is already joined. Now let's try to specify. Of course, you know that this would be our x1. This was our x1. This is a value for x2, and this is the value for our y1, and this is the value for y2. Of course, when I do this, see that we have kind of a right angle triangle here, and then we are asked to find the distance between the point A and B. Of course, if this is a right angle triangle, you can see that that distance is the hypotenuse, right? So remember, we're going to apply Pythagoras theorem. So from Pythagoras theorem, we have that the hypotenuse squared, which in this case is d squared, is equal to the opposite side. Now, what's the opposite? So if this is our opposite, let's say this is our opposite right here, what would be the value for that? Well, you see that if this is y1 and this is y2, then the distance between y1 and y2 would obviously be y2 minus y1. Just get the change, or rather the difference between the value of y2 and the value of y1. And then this side also, since this is x1, this is x2, the whole of this would be x2 minus x1. So we can apply this in the Pythagoras theorem and get the value. So it's going to be x2 minus x1, remember, all squared, plus y2 minus y1 all squared. So this is from Pythagoras theorem, that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. Now, since we are looking for d, we just make it we just get the square root of everything, on the left and on the right to get d. So d would be the square root of, everything we have there. So that would be the formula you need to know. This is the formula we use to find the distance between 2 points on a plane, the Cartesian plane. So anytime you have 2 points, you can always use this formula and get the, the answer. This is called the distance equation. So anytime we apply this, we're always going to get the answer. So in this our case now, remember our y1 is the value of y1 is 1, or rather the value of x1 is 1, the value of x2 is 4, the value of y1 is 2, the value of y2 is 6. So what if we're asked to find this distance a and b? We can now use this formula to solve. So our d, which is the distance, would be the square root of x subscript 2, the second value of x, which is 4, minus the first value of x, which is 1, all squared, plus our value of y2 would be 6 minus 2, all squared. So the distance between those 2 points would be the square root of 4 minus 1 is 3, 3 squared is 9, plus 6 minus 2 is 4, 4 squared is 16. So d would be the square root of 9 plus 16 is 25. So the distance between a and b will be 5 units. Alright, so this is for this particular problem. We can have a situation where the distance between them would be negative, positive, or anything depending on the coordinates that we're given. So I think this is basically it. So that's how to represent or describe the position of an object using the Cartesian plane and Also, this is the formula you always need to find the distance between 2 points. It is d equal to the square root of x squared minus x raised to x2 minus x1, x2 minus x1 squared plus y2 minus y1 squared. So you don't need to cram this. The formula is very easy, since it was, if you know the Pythagoras theorem, then you can let's remember this. Just remember that the distance would be the hypotenuse, and then you just find the values for the change in y and the change in x respectively, and then use it to solve. So that is it. Thank you for watching.